So next up, we have Omar ElNaggar, who is the CEO and founder of WeaveChain. Omar is truly a blockchain industry veteran with over 10 plus years of product executive experience across fields of data management and AI technologies in both Web 2 and Web 3. And as somebody who's had the ongoing pleasure of interacting with Omar through a variety of different DeSci activities and events, I can definitely say that many entities in the space would not be where they are today if it weren't for him and the amazing team at WeaveChain, which is essentially a layer zero for data in the space, right? It provides enterprise-ready solutions for entities looking to integrate their stack with Web3 technology.
Thanks, guys. And Jelani, what an introduction. Way too kind, sir.
Hey, man, it's always a pleasure to see you. So I will actually leave it at that since you are here and allow you to regale us and speak to us and inform us on how distributed storage plays a key role in, I guess, everything that we're trying to do and how WeaveChain kind of facilitates that.
Well, I appreciate it. I don't know if it's going to be as exciting as protein folding and such, but we're about to get nerdy as always on the data side of things, which I love. Let me start sharing over here. Well, hey, everybody, I'm Omar, the CEO and co-founder of WeaveChain, and I'm thrilled to be here at SciCon 2023. So thanks to Patrick and the ResearchHub team for hosting this event. And Jelani, I appreciate you inviting me to speak. Today, we're going to be talking about distributed storage, a subject that I'm passionate about in a way that's slightly off-piste from most people. But I figure we'll sort of break things down into the benefits, drawbacks, methods, and examples. So, we'll start with why we even care about decentralization, then jump into how it's actually implemented today, what are some of the drawbacks of it, as well as some examples of who's actually benefiting from this technology today. So let's start with why does the decentralization of data even matter? And at WeaveChain, we're very opinionated on this idea that what we're trying to do is really fight fraud and data abuse. So when it comes to fraud, people used to complain about bots and misinformation. But one of the interesting things is that last year, after FTX imploded, we just saw outright financial fraud come top of mind again, both for FTX, having $8 billion of assets and $10 billion in liabilities, as well as a lot of hedge funds that were exposed to FTX that literally just lied about their exposure and broke contracts for that. Now, in the age of AI, we're also seeing data abuse on an unprecedented scale. I think there's 8,500 lawsuits against OpenAI right now. Everybody from J.K. Rowling from Harry Potter to George R.R. Martin and Sarah Silverman. And the general idea is that, these people had clearly copyrighted material and, these AI are consuming that material and claiming fair use, which is a pretty clear violation of terms of service as far as most people are concerned right now. And the good news is that we can go and address these issues with things like decentralized storage. So at WeaveChain, we always try to say that we're trying to make data flows provable, where we understand the source of data, that it is backed by these cryptographic guarantees of immutability, and that you can see a lineage of how things have progressed. And then we are really promoters of data exchangeability, where individuals can own their own data, exchange it for digital currencies, and that could be for raw replication or for things like confidential computing. Now, let's dig into this a little bit deeper and talk about things like self-sovereignty, right? The ownership of data. And really, this is like the evolution from Web 0, which is, disks by themselves, to Web 1, which was really a lot of individual data silos, to Web 2, which were network data silos and data lakes, to Web 3, where people say we're creating this, cross-organizational mesh where people can really own their own data. And I actually really like one of the things that we worked on with the team over at Genoverse for this, where their vision is to go and enable individuals to own their genetic data and have an NFT that represents access rights to it. And we think of data governance in this case as three different patterns. An individual could actually let Genobank hold their data for them. This is the traditional SaaS model. Or ideally, we create this Geno Vault where I could actually host my genetic data on my personal devices, my phone, my laptop, or even use a third-party steward. So this company, Skyflow, is a very well-regulated data store that can hold anything from genetic data to financial data and everything in between. It should be the choice of users where you want to host your data, right? You should not be forced by, big companies like, Google and Microsoft, not to pick on them, to be the only people that would be the store of your data. You should have these rights. And then you should benefit from all those other properties I told you about earlier, access using wallets and NFTs, confidential computing, lineage. And then if you own your own data, you should be able to go and learn from your own data at any time. One of the interesting things that Ginaverse highlighted was that there was an open source code base for understanding whether you had personal Alzheimer's risk that had to be taken off a service like 23andMe because it was not FDA validated, but it was based off of open scientific literature. As a user, I should have the right to own my own data and study myself based off of these open source tools in a way that's very easy. And I think, the next step of the vision is maybe there's other researchers that want to earn from or learn about my data and are willing to pay me for it. I should be able to make that data available to them in a way that benefits me in a secure way. And I think a lot of people in decentralized science share this vision. We put this together. The team from Reputable Health had this vision of building this Web3 data economy where users would be able to exchange their data for tokens that could be purchased by these data buyers. And the idea was that you would have this mesh of users with data on their personal devices that would then provide access to that data through a WeaveChain node or another mechanism so that these big data buyers could come in and get access to these data sets. This is maximally distributed storage, where it's literally at the user level. And you hope to go and create this data mesh where different parties can go and benefit from this data on different levels. This idea has been promoted, but not just by people in decentralized science, but also the team at Vodafone had this vision of not the Internet of Things, but the economy of things. Imagine that every device out there is generating data that's available for purchase at any moment in time in a way that's completely frictionless and really just needs you to say, I am willing to consent to sell this data if you are willing to pay me, and then let the revenue streams come in. Now, moving past self-sovereignty, I'll note that a lot of people in Web3 are big promoters of this idea of censorship resistance, meaning that if I'm hosting my data personally, as opposed to Twitter hosting my data, well, then there's no way that they could just go and take down my content based on a whim, for example. Now, full disclosure, I know that this is something that people in Web3 are very passionate about. I am not as much of a proponent of it because I feel like laws are laws. So, as we saw with the Tornado Cash incident, where we had a fully decentralized protocol running, governments were still able to say, yeah, sure, your wallet is self-sovereign, but if you go and interact with this protocol that we have identified as illegal, I'm going to blacklist your wallet and make it so that you cannot withdraw money from bank accounts anymore using it. I do think that's going to be a case with most of these peer-to-peer services, no matter what. But I appreciate that a lot of the space is very into censorship resistance. More interesting to me is trust through consensus. And I really like this slide that the guys at Chainlink had, last year at their kickoff, where they were talking about this move from paper guarantees to cryptographic guarantees. And this is really what I think Web3 was designed to do really well, is make it so that it's not like don't be evil, it's more can't be evil, right? If I have these guarantees at the data layer, then it's impossible for me to commit financial fraud, for example. And to explain this concept, I'm going to use an analogy based off of this verifiable credential pattern. And the idea is similar to a driver's license in your wallet, right? I go to the DMV, they issue me a driver's license, I hold in my wallet, and I can go and present it to the bar, and the bar can actually scan the barcode on the back of my driver's license, validate that it was issued by a government agency, and that I am 21 or older, and then I get to drink. This pattern is the same pattern that's used for HTTPS certificates, and it was made a W3C standard just last year, and we think it's going to be used for everything. So if we move past the driver's license example, when we talk about HTTPS security, this is what your browser uses to identify that a website is authentic. All right, that little lock icon over here, it makes sure that the website you're interacting with is actually docs.google.com and not somebody who's spoofing that address. And it makes sure that once you set up that communication channel, that nobody can tamper with it. For example, a government agency injecting something into your stream to docs.google.com to present you with something that you, let's say, didn't actually come from the source. But it's using the exact same pattern as that DMV example, right? Google will issue a signed certificate in this case, and then I will validate that certificate. We'll set up a secure tunnel for our activity, and then we'll go and do all of our activity through that secure tunnel. Now, this encryption technology took literally 25 years to reach mass adoption. When it started off, people were just like, it's slowing down my websites, and they hated it. And then, we had a few high profile breaches. In 2010, you couldn't go to a Starbucks and use Facebook without getting hacked, for example. And in 2013, it turned out like, everybody from the NSA to China was actually hacking these HTTP streams. And we think the exact same thing is happening right now in this migration to, Web3 data and utilizing things like distributed storage. So when it comes to Web3, we say that what we're trying to do is establish a shared immutable ledger. And the problems that we are dealing with are when you have unpermissioned writers trying to write to a database, and when the participants try to tamper with history. And the general idea of most consensus mechanisms is that, let's say A over here is going to go and initiate a write to the network. B and C will acknowledge that A is doing some writing over here, and then they'll all update their local databases, and then they'll go and update a blockchain, which is a way to go and ensure that we all maintain this shared history and that nobody can tamper with it. Now, we think that this is the kind of technology that's going to go and apply to things like scientific research to ensure that people cannot commit fraud for results. So, there was a great review from the NHS just last year talking about how they wanted to go and leverage the power and potential of all this data that they've collected. And one of the key things here was to establish, reproducibility in scientific pipelines. We use these shared distributed ledgers for exactly this purpose, to go and say, I want to go and have this shared immutable ledger of the data that's being stored, the computations that are run, and the results, and make sure that that fraud can't happen over there. And they also talked a lot about confidential computing, which I'll dip into a little bit later. Now, the last benefit that I'll say from distributed storage is permanence. And this is, Weave's forte right here. They are the permanent information storage service for Web3. But, even if you're going and putting data into a smart contract on Ethereum, for example, you should be establishing permanence for that data, for better or worse. And the cool thing here is that you have services like, DeSci Labs, DeSci Nodes over here, which are trying to go and attach all this metadata to research paper objects. Well, you want as much of that as possible to be permanent and there forever, so that, again, people can't go and tamper with it, and so it's always available for researchers. Now, how are people actually going and achieving these interesting properties of decentralization? Well, let's start with how things were done in the past, right? Let's say that I have some data that I'm trying to sell out to you, the buyer. Most likely, I'm going to go and put that data onto an FTP server or in some demilitarized zone. And then, I can put as much data as I want over there, and you can go and pull it from that location that you have access to. That's okay, but, again, we have none of those interesting trust properties that I mentioned earlier from decentralization. If you're going to go and use a permissionless storage mechanism like IPFS, for example, what you do is say, all right, I am going to go and encrypt my data and put it into this public storage mechanism. In IPFS, everybody can access all data there, but if they don't have the keys, they can't unlock it. So when I have a buyer over here, I need to first go and give them the key to go and decrypt that data, and maybe I'm going to sell them that key, and then they can go and pull the data over here into their local mechanism. This is a really interesting way to manage, public goods, and we're big supporters of it. At WeaveChain, we have a slightly different approach where we go and let people set up Weaves in their local environments for, let's say, their private data sets for healthcare data, financial, you name it, attach their local database to the WeaveChain node, and then go and have their consumers connect to the Weave and then potentially pay to replicate raw data with no third-party mechanism in here, right? It's fully peer-to-peer, where it's me and you sharing data directly with each other in a way that's synchronized. And we want to make it so that you don't have to go and put your data into another third-party service. We want you to be able to connect your existing database right there in line. And same with the consumer. They already have a database. They should just go and connect it to the WeaveChain node locally, and then they can go and deal with fees and paying for data. Now, I wanted to go into one subject that is a different way of accessing data that I still fits into this sort of theme of distributed storage, which is confidential computing. And in a confidential computing scenario, I'm not giving you the data itself. I'm giving you access to the data so that you can run some computations and learn from it without exposing the raw data. So let's say that I thought there was a really good talk from the head of Walmart's data governance back in 2022, who was talking about how Walmart considers all data that they hold effectively a liability. They know that they are subject to regulations from this data, and they're really trying to minimize how much they have on-prem and making sure that what they do have is actually worth it. And there's new services that are coming up like Skyflow that are really good for actually hosting this data. But better yet is if you don't have to host the data at all, and you can just sort of benefit from it using something like confidential computing. And what we mean by this is, let's say that I am a hospital that has patient data. I can't just go and give my raw copies of patient data to other people. It has personal identifiable health information, and that's just not appropriate. What I could do, however, is tell somebody, I will give you a schema of the data, and you can go and design some analytical process on your side, and I will let you run that process on my servers and give you the results, but not the data itself. And a better way to describe this is using slides that I have stolen from David Aronczyk of Bacalhau. David, thank you very much. He was able to describe this really nicely where, org A, again, is that sensitive data holder, org B wants access. Org A is going to go and say, give me your job. Give me the computation that you want to run over here. I will go and look at it to make sure you're not exfiltrating data. And if it looks okay, I will run it against my data locally, create some results, make sure that there's nothing sensitive in those results, and then give them back to you. This is how we actually see future data flows happening, as opposed to, let's say distributing storage rights. And we're really excited about it. This can happen in a one-to-one capacity, as we just looked at, or I could have my my analytical process that I designed and run it against decentralized data sets, right? Where each of these parties hosts the data in a self-sovereign fashion, but makes it available for computation. And there are a variety of different techniques for doing this. Compute to data is what we just looked at, where it's sort of one-to-one. Multi-party computing can do things like a simple algorithm across multiple data. Federated split learning is great for training machine learning models. And then you have things like zero knowledge proofs, Merkle trees, homomorphic encryption, et cetera. Now, this is all well and good for how these cool tools can work, but what's the catch, right? And unfortunately, there are a bunch right now. We are still in the very early days of Web3 storage. And I'll be honest, right now, a lot of these services cost more than if you were just gonna go host data yourself and serve it up. Even services like IPFS and Filecoin, I've talked to the providers that say that at this point, it's like 2 to 3 times as expensive as just hosting things on AWS, because you still need to establish redundancy and you still need to go and make sure that you're paying for that usage. And unfortunately, a lot of the incentives are just not there anymore. Additionally, it's not as performant, right? If you are going to be synchronizing with a blockchain while you're doing all these interesting things with the data, well, that's going to be more expensive than just accessing the data by itself. At WeaveChain, we say that we're about like a 10% performance penalty on top of a database for read operations and 20% for write operations. But if you go further down the rabbit hole towards things like zkML right now, that's 1,000 times more expensive computationally than just doing things natively. And it's not necessarily easier either. Interacting with IPFS has all kinds of challenges for availability and nodes and things like that. And we're all like very used to building directly on databases at this point. There are billions of libraries and Stack Overflow articles that get up to speed, and that's just not the case for a lot of these Web3 services. And the last one, which is one that I focus on quite a bit, is compliance. So, we used to say that like building Web3 is miserable at best and illegal at worst. We know there are challenges with fully centralized architectures, but when you go into fully decentralized architectures, a lot of times you lose things like GDPR and HIPAA compliance. And so we say that a lot of times these things are best for public goods, things that don't need GDPR compliance because they're already public and available to everybody. And the thing about GDPR compliance is that you need to be able to erase data. And if your ledger is permanent, like Arweave, well, you can't delete things. So that means you can never put data that has to be GDPR compliant there. And same for HIPAA, you need physical safeguards. If I'm going to dive deeper into this, again, the core idea is that public and permissionless Web3 cannot forget. Therefore, you cannot satisfy a GDPR erasure obligation. So if you are the user of a service that wants to, and the users are citizens of the EU, they have a right to ask you to delete your data, and you just can't do that if the data is on Web3. And for HIPAA compliance, you need physical safeguards. You need things like firewalls. Encryption is a technical safeguard, right? That's one of the three categories that's required over here. But again, if you have no firewall for your data, then you are perpetually in a breach state. We like to say that WeaveChain is the sweet spot of data storage centralization, where we utilize these smart trust networks for data sharing that are private and permissioned and utilize firewalls. So our vision of the future is that most data is going to be in these sort of networks of specialized networks, where hospitals may be sharing data with each other so that they can go and provide better care. Financial entities may be sharing financial data so that they can be more efficient. And this is a way that sort of satisfies the legal obligations of today, as well as the features that we want out of data tomorrow. We call our pattern a layer 0 for data, where we start with, again, these truly self-sovereign nodes that share data with other parties in a private DApp pattern. And that could be a data DAO or even just an individual user running an app in their browser, for example. But these side chains or private dApps are completely isolated from each other, where not one bit flows between them. The way that we achieve the security of Web3 is by actually anchoring our data to layer 1, layer 2 protocols. We call it like a data rollup for security. And the idea is that I can go and take a one-way hash of data. And what it shows me is that this data will always create this hash. It's a deterministic algorithm. And if I change the data in any way, it wouldn't recreate the hash, and I can never use the hash to recreate the data. If I put those hashes onto a blockchain, then I'll have these timestamps that guarantee that like this data made this hash at this moment in time, and nobody could have written to that blockchain or edited with the order unless they were the owner of the smart contract and permission to do so. Or if they were able to actually hack the blockchain itself, which thankfully is not happening for pretty much all the major networks that you know and love today. So the last bit I want to talk about is who is actually benefiting from this technology today. And I will note that Web3 storage is still very, very experimental. We're in the early innings here. So again, for using most of these public and distributed storage mechanisms, I really think that academia has shown good progress so far, as well as the government public goods, where things like compliance are not quite as big of a concern. We've also seen a lot in media. So, that could be from storage of monkey pictures for NFTs, but we're also seeing the emergence of the use of distributed storage for licensing content. We are working on this very heavily at WeaveChain, where we're trying to license data and computation for what we're calling, the Napster moment of most media. I mentioned earlier, large language models are really sucking up a lot of data under the guise of fair use. And I just don't think that's actually appropriate for most of these people that have generated copyrighted work. So one of the companies that we're working with has this challenge where once data leaves its walls, they can't differentiate between what's legal and what's illegal, right? If somebody comes and scrapes their website, how do I tell that that's scraped data versus the data that was acquired through a purchased API? And the reality is that the only way you can protect data on your website right now is with a little file called robots.txt that's like, hey, robots, please do not come and get my data. And the reality is that suggestions are just not an effective defense, right? That file at Twitter says, to every robot that might possibly read and respect this file, please do not scrape my data. And again, it's just not working. So what we do is we go and provide them with a licensed data API that comes with a signed manifest. We're collaborating with the Content Authenticity Initiative that was sponsored by Adobe, and we anchor that data to Polygon so that it's very clear what legal data looks like versus illegal data. And what's really exciting is that we're taking that the next step by then saying, let's go and show what a licensed large language model looks like versus an unlicensed one. Where if we go and run a training algorithm through WeaveChain, what we're putting on the blockchain this time is not a proof of data, but a proof of computation. But again, we are decentralizing that amongst multiple parties and showing how to have these cryptographically secured trust economies. So here we create that computational lineage, we put the proofs on chain, and then it's very easy to show what a bad black box LLM looks like versus a good one. And we think that this is really the future. Senator Blumenthal and Hawley just released their framework for, the AI, US AI Act. And it is very clear that most large language models are going to be licensed in the near future. They'll be subject to audits. They'll be responsible for the data that they trained upon, and they'll have to be including things like watermarks and public registries. Our bet is that today's LLMs are these Napster era black boxes, but really the LLMs of the future that people are using are going to be these massive ones. Another place where we're seeing decentralized storage working a lot is in finance. So one of the coolest case studies that I've seen was this consortia of over 100 banks in Italy that are deprecating trade reconciliation processes using distributed storage technology. So the idea is that, like, you know, if I am a customer of, let's say, Goldman Sachs, and I go and execute some trades with them, and Goldman Sachs is actually interacting with JP Morgan for those trades, at the end of the day, Goldman Sachs and JP Morgan will have to go in and share a bunch of CSV files of trades with each other to make sure that their books match. Instead, if they were just using one decentralized storage mechanism for those trades, then there would have to be no reconciliation process. And theoretically, you would have massive efficiencies gained by this. At WeaveChain, we work on a solution for verifiable financial data that does things like proof of reserves or proof of solvency, as well as proof of custodianship for this data. And the challenge here that we were facing for a lot of these hedge funds is that they did not want to use Web 2 SaaS solutions. So Credora is a really cool service that's actually using confidential computing in a cool way. The problem is that they are a SaaS service. And so the only way a hedge fund can use them is if they say, okay, Credora, I'll give you my private keys so that you can go and download my position data to your servers and create a report based off of this. This, unfortunately, is puke-worthy for most people in finance. You know, I ran R&D at a hedge fund. We didn't use AWS. Like, we hosted our own data centers so that nobody could go and see our position data. And if you're doing a public DApp, you know, again, we're saying maybe it's okay if you encrypt your data and put it on IPFS. I don't think so if you're a hedge fund. What we say is, let's do this in a peer-to-peer fashion. Our private dApps have no data on them. The hedge fund actually hosts a WeaveChain node with its own database locally so that it can load its positions through the WeaveChain node into its local database. And when it creates a report, it shares it peer-to-peer with that lender like Maven 11. And Maven 11 can go and receive these reports peer-to-peer across all these users in a way that is, you know, decentralized, but again, trusting no third party, none whatsoever. In this model, we really think it's all about, like, who is that trust network? In this case, it's, you know, hedge funds, lenders, and people like fund administrators or credit rating agencies. You're always going to need somebody who can go in and see the data in a raw format, because, you know, the problem with proof of reserves when it came to FTX was that they had a surprise $10 billion liability that they hadn't told anybody about. You need humans in the loop for that part. You also need humans in the loop if you're going to utilize zero knowledge proofs, right? A zero knowledge proof is only useful if both parties have the raw data and then are using the ZKP to check each other. The last use case I'll mention over here, which is particularly useful to DeSci, is healthcare. And you know, full disclosure, I think this space is also still pretty early, but we're excited about, like, you know, the marketplace that we built for Genobank, the Genoverse, where you can come with your bio NFT from Genobank and then go and click on a bunch of these services and learn about yourself using confidential computing, where I can see the results of my heart disease report and nobody else can, not even Genobank. You know, we did a lot of fun things with them with ChatGPT. It was all cool, but again, this is early days. The project that I'm, you know, full disclosure, most excited about is Data Lake. You know, they have partnerships with the government of Poland, the EU, and they recently did a partnership with Novartis that I'm thrilled to see materialize. I really think that this is where the space needs to go, is merging the principles of decentralized science with you know, traditional science practitioners that can bring a big budget to bear and get the best of both worlds. I know I covered a lot today. You know, we went through sort of why this matters, how it's actually implemented, what are some of the drawbacks, and who's benefiting from it today. But it's really an exciting time for this space. And of course, anybody's welcome to reach out to me. I'm Omar ElNaggar on Telegram. I'm in all of these blockchain for science chats and DeSci world, and you're always welcome to reach out with an email anytime.
Amazing. Thank you, Omar. I think that was a very, very comprehensive look at the opportunities and also limitations that exist within the distributed data storage solutions, I guess, that exist right now. I like that you broke it down per industry. I do think DeSci's largely focused on the healthcare industry, but that's subject to change. So things like considerations of not really needing to mind GDPR and HIPAA and bringing in fields and disciplines and industries that don't have those considerations, it's almost more catered to that. And we're kind of starting from the ground up through the difficult pathway, but it's still very interesting to see. One point that I think keeps coming up in my mind and having the pleasure to go through this industry or go through this space is that we often talk about like data silos, right? And how Web3 is, I guess, in theory, or at least the ethos is to get rid of data silos or to help bridge the gap between data silos. But if you think about it, or at least if I think about it, if you're going to give every individual data provider or data generator a specific key which allows them to exclude other people, you're now creating small but consistent data silos across. And so how do, from you as a person who is very pragmatic, deals with enterprise, like how do you see that reconcile with the Web3 ethos? And just disclaimer, DeSci leverages Web3 tooling, but I think DeSci as a concept exists beyond that. It even exists beyond a variety of different frameworks that we're presenting here. But I'd love to kind of get your perspective on how do we reconcile that? Are we effectively creating just smaller data silos? And are we going to see things where prices to access get ramped up because each individual is like, oh, this person is charging more, I'm going to charge more, and it just keeps scaling?
No, it's a great question. And, I have this conversation oftentimes, weirdly enough, with my wife, and I talk about partial progress being okay. And it's like, it's very controversial because especially in Web3, you have a lot of people who are sort of maximalist about these things and saying that, look, if we're going to go and do it, it needs to be fully public and permissionless, decentralized from the start, and we'll figure out how to make that work. But that's, again, like a hammer in search of a nail kind of thing. So like my perspective is, again, the goal is, let's go and take one silo and let's go and figure out how to bridge that across 5 hospitals to start instead of, every hospital in the world. And if you do that, you're doing a really cool thing. Like you're making it so that, what Data Lake is doing with their consortium of hospitals in the EU is really effective at data sharing. And it's a lot easier to sort of add people onto that bubble as it starts to grow. And I think that comes back to my point earlier, which is there is a middle ground over here where you are not fully centralized and you are not fully decentralized. You are sort of dealing with the requirements of the time to make progress towards it. And I think that's how we're going to do it. So again, it's a sort of land and expand and attach as opposed to just rip and replace and be sort of hyper idealistic about it.
Cool. One thing that I hope to see, and I'm sure, well, you can actually let us know if you see that in the framework, but one of the biggest issues that we have from this data siloing or this lack of interoperability is not a intent-based issue, but more of a lack of standards that exists between players, right? So a lot of it is really unintentional. And it's just that the way that I have my file structure or file format it's not compatible with how you have that. And I imagine things like WeaveChain, and when we start to create, and what Data Lake is doing, and what Genobank is doing, is you're creating these frameworks where players are not necessarily incentivized, but start to play with one another. And I hope that the goal moving from that is that we start to have these conversations where we can, and especially when you have decentralized or federated learning, distributed computing, where you have that like assuredly where you own or you maintain sovereignty over, or the entity maintains sovereignty, we can start to have this shared standardization or this generation of just a global standard in a particular industry that can help further facilitate that. Is that things that, yeah, so I know that's a goal, and personally in my endeavors, that's what I would love to see. Have you seen some of that coming to the forefront? Is there conversations that exist around that within the field of distributed storage that is, kind of showing or giving an inkling that it's maybe going in that direction?
100%. But, and I want to, it's almost like more about the standards themselves than it is about the mechanisms for using it. So I'm part of a committee with Keith Comito, where we're trying to go and establish standards for how you actually do like device level standardization of data for measuring, Alzheimer's treatment and things of that nature. I'm doing a talk at the AHAIMA on sort of like blockchain and data sharing on these things. But for all these, it like comes down to, are you going to figure out how to, just get people to use things like fire standards, things that already exist. Again, I think what Data Lake is doing is really special in that regard, because they have connected to like 200 different hospitals in the European Union and created a standard for themselves that they can do it with. So it's going to be a long slog to go and get these things to happen, but it is happening. And I would just say, like, separate out the interface from the storage mechanism as much as you can. Like, it comes to, for us at WeaveChain as well. We really try to say, like, I will go and let you use whatever storage mechanism you want for this data. It could be IPFS, it could be PostgreSQL. I don't care, but once it comes to this bubble, the interactions between them need to happen through a fire standard or something equivalent to make sure that again, we have the potential to scale when it gets there. Because at the end of the day, you remember we did this talk at DeSci Denver. It was like, why does interoperability matter? That's how you get to internet scale applications. And we want to see this for things like healthcare as well.
Amazing. Well, I have a few questions, and I'm sure other people will as well. So if you do, please go reach out to Omar himself, interact with the WeaveChain community. As you can see, it's very nice, very, very approachable individuals. And yeah, you can learn a lot. So Omar, again, thank you so much. It's always a pleasure to see you. And I will see you at our, I guess, next event where we converge. Have a great rest of your day, man.
Thanks, Jelani. Thanks, everybody.
Take it easy.